Good afternoon, everybody. It's my pleasure to share the work I did last year with you. At the beginning, I awarded a Fulbright scholar for only 4 months to work at Woodman Center for Photomedicine. This center is at Mass General Hospital, which is a Harvard Medical School affiliate. And at the beginning, I was planned to work with Dr. Taiba Hassan. She is a professor there, but because of her travel, she introduced me to one of the young researchers that awarded his assistant professor degree, Dai Tan Hong, and officially he was my main mentor. I'm a microbiologist and I'm interested about antimicrobial resistance, and actually Newsweek published an article last year about the microbial resistance. And they said that the microbial resistance increase more and more, and the drug will not work anymore. And we need to find a new approach for working with an antimicrobial agent rather than antibiotics. One of which is the phototherapy, which I'm interested with because I worked at the National Institute of Laser Enhanced Sciences. And photomedicine, as example, blue light or phototherapy by using blue light. Blue light has many clinical applications. As example, dentists worked with blue light for the treatment of Porphyromonas species or for sterilizing the pockets inside the gingiva. And also by the same way, dermatologists working with blue light for eradicating of the bacteria that cause acne. So it has many clinical applications. What is the accepted mechanism of action or the hypothesized mechanism of action? Actually, the accepted mechanism until now, the presence of endogenous photosensitizing agent, mainly porphyrin. This porphyrin, when exposed to blue light, it will be excited and change into a triplet state. This triplet state may release reactive oxygen species or release free radicals that have a destructive effect on bacterial cells. In my work, I worked in vitro on Pseudomonas aeruginosa as one of the most common cause of hospital-acquired infection. About 10% of hospital-acquired infection caused by Pseudomonas, and I irradiated this Pseudomonas or this bacteria by using a blue light source with different energy doses, and the result shows that by increasing the energy dose, the bacterial inhibition increased more and more. Also, I studied the bacterial resistance toward the blue light, and I found that there is no evidence of bacterial resistance, because of the blue light, which is good. In order to prove the hypothesis about the presence of photosensitizer or an endogenous photosensitizing agent inside, mainly porphyrin, I work with HPLC. I make an extract from the bacteria to identify the presence of this endogenous photosensitizer. And yes, our bacteria have this endogenous photosensitizer, porphyrin, in compared to the HPLC pattern of the standard porphyrin kit. At this stage, I got an idea that I'd like to transfer my research from bench scale to the field study, or meaning to work on animal. I've never worked with animal before, and this was the first time in my life. I submitted a proposal to a Fulbright to extend my stay, and I get granted an extra 7 months. And then to work with, I start working with my mice. And as a typical woman, I behave like a typical woman, so... Oh, yes. Yes, I behave like a typical woman, so am I. And this was amazing at the beginning, but after a good training and after I attend many exams, I get my license and I'm allowed to work for an animal facility for 3 years. And by the way, it's a very complicated process. It takes about 10 steps. I have to pass the exam, attend the well training, and after that I start designing my experiment. I induced a wound infection on the dorsal view of the mouse, and then I infected this wound by bioluminescent bacteria. What's bioluminescent bacteria? It's a bacteria that emit light, and according to this emission of light, we can decide whether we have a live bacteria or the bacteria is died. In order to assess the treatment effect of the blue light, the mouse irradiated with different energy doses, and both irradiated and unirradiated mouse were exposed to a bioluminescent imaging system, which consists of a CCD camera and an imaging box and camera controller. And then I gain my results. these images. The first panel A showed the images of the mouse infected with a bioluminescent bacteria treated with different energy doses from blue line. And as we see, there is a great reduction in the bioluminescent emission, indicating that the real eradication of bacteria, until we reached the dose 48 joule per centimeter square. A complete eradication of bacteria was done. At panel B, we can see this is an untreated mouse infected with the luminescent bacteria, and we can observe that there is no change in bacterial luminescence. So there is no treatment, and this proves the efficacy of the blue light for the treatment of skin wound infection. Then I started my second extension, and this time I get my appointment as a professional staff at the MGH. I get my contract for 1 year as a research scientist, but unfortunately due to critical family concern and health issue, I had to return back after 3 months from this appointment or from this contract. Although I returned back, but I didn't stop my collaboration with my counterpart, Tian Hong. I continue working with him via email. And then I submit an abstract to the European Society of Photo Medicine, and I give an oral presentation about my work. And currently we are preparing a manuscript to submit it in one of the relevant journals. In order to extend my collaboration, or to extend the channel, to open a channel with my collaborator, with my American collaborator, I involved him in one of the work that I did in Egypt. And recently we have got one accepted publication just 2 weeks ago. This work was done in Egypt, and just the analysis and reviewing process was done between me and between my counterpart at the States. Actually, I summarize now the achievement I've got on the professional level, but on the personal level or on the social level, I've got many experience. I've got experience with an American culture. I traveled alone with my 2 kids, and they joined public schools. I attended almost all the social activities that prepared or that held in my host institution. Fulbright prepared a good rule for going to an excursion activity. I attended almost all the excursion activity. This was at all the Starbridge Village, and also I attended whale watching. This was at Newport. I also visited a Native American museum. I attended all the activity, almost the whole activity, and I traveled not only with my kids, but also I invited my dad to come and visit America for the first time in his life, and he spent 1 month, and he enjoyed his stay in America. And of course, my husband went back to visit America because he couldn't leave his work. And finally, I'd like to thank you for your attendance. 415 nanometer. 415, it's invisible region. 415. Visible, yes, it's visible. Yeah. It's visible region, yes. Sorry? Why? Because the porphyrin or the endogenous porphyrin absorbed mainly in this area.
Thank you.